Welcome back. This is Mr. Hassan's Maths channel, and this is a question that I'm going to answer from the P4 International A-Level Edexcel textbook. A question from exercise 2C about partial fractions, question number 3. It says, given that ax squared plus bx over x minus 1 times x plus 1 can be expressed in the form 2 plus 5 over 2 times x minus 1 plus c over 2 times x plus 1. Find the values of a, b, and c. Okay, now in this type of question, it's slightly different from what we normally have in partial fractions. Normally you have everything on this side and you're going to express it in this form and you don't know like what these numbers are. So, I mean, in order for us to solve this, we should understand the process that we go through when we are dealing with partial fractions. Okay, not just memorize exactly every step, because if you just did that, then you wouldn't know what to do in a question like this. So what you need to realize is what we do is we know that basically ax squared plus bx over x minus 1 times x plus 1 is identical to 2 plus 5 over 2 times x minus 1 plus c over 2 times x plus 1. Now, what we normally do is we try to get rid of the fractions, and we try to deal with, when we're making partial fractions, we try to find the values of the letters on this side normally, and we get rid of the fractions. So to get rid of the fractions here, so that we're left with just, whole numbers, we multiply by the LCM of the denominators. Now, in this case, the LCM of the denominators is actually 2 times x minus 1 times x plus 1. All of that is LCM of the denominators, and if I multiply every term by that, I will get rid of the fractions. Okay, that's an easy way to get rid of the fractions. So if I multiply this side by 2 times x minus 1 times x plus 1, well, the x minus 1 and x plus 1 will cancel out, and you're left with 2ax squared plus 2bx. If I multiply this term by that, I'm going to get 4 times x minus 1 times x plus 1. This term by that, the 2 and the x minus 1 cancels, leaving you with just the x plus 1, so 5 times x plus 1. And then if I multiply this term by this, the 2 and x plus 1 will cancel, leaving you with c times x minus 1. Okay, the 2's cancelled out and the x plus 1's cancelled out. Okay, so now we can look at this and try to deal with finding the values of a, b, and c. Now, if we were to use substitution, like when x is 1, these two brackets will disappear. I'll be left still with a and b, and I'll have to use some sort of simultaneous equations maybe later on. If I was to put x equals minus 1, these two will disappear. I'll be left with a, b, and c. So substitution doesn't seem like a very productive method here. And as I mentioned when I was teaching you guys in class, that we need to have a variety of methods. And one of the methods that many students probably are not so comfortable with is comparing coefficients, which you should be within your, ammunition basically to deal with these questions. So what you need to do is you need to think about how to compare coefficients that will make life easier in this particular type of question. So for example, if I compare the coefficients of x squared on both sides, on the left side I've got 2ax squared, and on the right side the only x squared term is going to be generated in this when this bracket is expanded, and you'll have this will give you x squared, and it will be times 4, so it's 4x squared. So 4 is the coefficient of x squared on the right side, so this quite easily gives you a equals 2. Okay, now once you've got a equals 2, you can then maybe, if you want to use substitution, you could, because for finding b, for example, or you could go on to, for example, look at the constants. If you look at the constants, you see on the left side you have 0 as your constant. Okay, because you just got 2b times x. On the right side, the constant's going to be when you multiply the minus 1 by the plus 1 and the 4, and when you multiply the 5 and the 1, and when you multiply the c by the minus 1. Okay, so you're going to have, this is going to be minus 4, what am I talking about? So minus 4, because you're going to have minus 1 times 1 is minus 1 times 4 is minus 4, and that will be plus 5, and that's minus c. Now, you can see from here we can find what c is. So if you rearrange this, you're going to have c is equal to minus 4 plus 5, which is 1. So we know now a is equal to 2, and we know that c is equal to 1. Now what we're left to find is b, and it's quite obvious if we look at the x terms, that's going to help us find b, because b is going to have a coefficient of x here. So if we compare the x's, on the left side there's 2b x's, and on the right side the x terms are going to be given by, well, if you expand this, the x term is going to disappear. You'll have x squared minus 1. There will be no x squared term, no x term when you expand this bracket. So you'll have 5 from here, and you'll have plus c from there. We already know, we already know what c is. C is equal to 1. So we can say 2b is equal to 5 plus 1, which is 6. So 2b is equal to 6. So we can say b is equal to 3. And there we have the answer to that question. Okay, so it's just a case of getting rid of the fractions and then comparing the coefficients. I guess you could have multiplied by x minus 1 and x plus 1. Without getting rid of the 2's, you would have ended up with fractions on this side, and you would still get the same answer. But I prefer to just get rid of all the fractions, so I just look at the LCM of the denominators and multiply everything by that, and that normally makes life easier. Okay, so I hope that was clear and you understood now how to do that question. Thank you for watching. Other questions from the from this chapter of or this topic of partial fractions from P4 will be found in this playlist over here, and other questions from the P4 textbook I'll put in this playlist over here. Thank you for watching, and I will see you again soon.